All right, today we're going to dive into a device you probably see all the time, but let's be honest, rarely think about. I'm talking about the small but mighty miniature circuit breaker, or MCB. It really is the silent guardian hiding in your walls, and you're about to find out just how important its job really is. You know the sound, right? We've all been there. You've got the microwave going, you plug in the coffee maker, and bam, click. Everything goes dark. Now, it's easy to get a little annoyed in that moment, but that sound, that's not an inconvenience. It's actually a signal that something incredibly important and potentially very dangerous was just stopped in its tracks. You see, that click is the sound of safety. It's a tiny, brilliantly engineered bodyguard that just sprang into action to stop a much, much bigger problem from happening. So let's pull back the curtain and see exactly how this little box keeps you and your home safe from total electrical chaos. Okay, so to really appreciate our hero, the MCB, we first have to get to know the villains it's designed to fight. And it turns out your home's wiring is up against two very different but equally dangerous kinds of electrical threats. First up, you've got the overload. You can think of this as the slow burn. It's like a traffic jam on an electrical highway. You've just got too many appliances trying to draw power at once, and the current creeps just a little bit above safe levels. Over time, that extra current generates heat, which can literally melt the insulation off wires and start a fire. Then you have the complete opposite, the short circuit. This is the sudden zap. It's a violent, instantaneous surge of electricity. We're talking hundreds of times the normal level, caused by a fault. This can create an explosive flash in less than a blink of an eye. So, the big question is, how does one small device protect against both a slow, creeping danger and a sudden, violent one? Well, it's because the MCB basically has two distinct superpowers, each one perfectly designed to counter one of those threats. First, let's talk about the overload watcher, a component called the bimetallic strip. This thing is so clever, it's just two different metals, say steel and copper, bonded together. Now, when an overload causes that slow, steady increase in current, this strip starts to heat up, and because those two metals expand at different rates when they get hot, the strip starts to bend. It's patient, it waits. And if that overload condition continues, it bends just far enough to physically push a lever and trip the switch. Simple, but effective. But for a short circuit, you don't have time to wait for things to heat up. You need instant, split-second action. And that is the job of the short circuit sentinel, the solenoid. This is basically just a coil of wire. Under normal conditions, it does absolutely nothing. But when that massive surge of current from a short circuit blasts through it for a fraction of a second, it becomes a powerful electromagnet. And that magnetic force instantly snaps the switch open. It's a lightning-fast magnetic reflex, no waiting required. So let's put it all together in the trip sequence. A fault happens. Either the bimetallic strip slowly bends from heat, or the solenoid instantly triggers from a magnetic surge. Either way, that action forces the internal electrical contacts apart, breaking the circuit. But here's the really cool part that most people don't know about. When you break a live circuit, you create a really dangerous electrical spark called an arc. Well, inside the MCB is something called an arc chute. It's a stack of metal plates that literally slices that arc into smaller, weaker pieces and snuffs it out safely. So it's not just about cutting the power, it's about doing it without causing another disaster. Now, as you can imagine, not all electrical circuits are created equal. The circuit for your bedside lamp has very different needs than the one for, say, a giant motor in a workshop. And that's why MCBs come in different types, which are really just different levels of sensitivity. The most common ones you'll run into are types B, C, and D. A type B is your standard household breaker for things like lights and outlets. It's pretty sensitive. It'll trick if the current gets just 3 to 5 times its normal rating. A type C is a bit more forgiving. It's for things with small motors, like fans or a fridge, that have a tiny power surge when they kick on. It waits until the current is 5 to 10 times the rating. And then you have the type D, which is the real heavy hitter for industrial stuff like huge motors that have a massive power draw when they first start up. It won't trip until the current is 10 to 20 times the rating. The whole point is you have to match the breaker to the job to get the right balance of protection and performance. And it's not just about sensitivity either. They also come in different shapes and sizes, from a single pole breaker protecting one simple circuit to a double pole for a big appliance like a stove, all the way up to 3 and 4 pole breakers for complex industrial power. It's an incredibly scalable system of protection, tailored for just about any need you can think of. Okay, so you might be wondering, how can we be so sure these little plastic boxes are going to work perfectly every single time? Well, it's because these things are absolute marvels of tough engineering, and they are built and tested to incredibly strict standards to make sure they never, ever fail.
Seriously, every single part, from the super tough heat-resistant plastic case on the outside to the electrical contacts and that critical arc chute on the inside, everything is designed for one thing: fail-safe reliability. There are no flimsy parts here. The precision engineering that goes into what looks like such a simple switch it's remarkable.
And before any MCB ever makes it into a wall, it goes through a brutal series of tests based on strict international standards. They flip it on and off thousands of times. They carefully heat it up to make sure the thermal trip works at the exact right temperature. They hit it with a massive short circuit current to prove it can handle the absolute worst case scenario. Its insulation is even zapped with high voltage to make sure it's safe to touch. These devices are literally tested to perfection, so they're ready to fail, in exactly the right way, at exactly the right time. So the next time you hear that click and the power goes out, don't just see it as an interruption. See it for what it truly is: your home's silent, tireless, and absolutely essential electrical bodyguard, doing its job flawlessly. It really makes you wonder, what other hidden guardians are quietly working all around us, just keeping our modern world running safely?